Hello everyone. My poster is about photoluminescence enhancement studies of naphthalocyanin dye doped silver nanocolloid. The main objectives of this work are the green synthesis of silver nanoparticles using Saraca declinata leaf extract as reducing agent to find out the effects produced by gamma irradiation of various dosages on the samples and to compare the result with that of the samples without irradiation, the characterization of silver nanoparticles by UV visible spectral analysis, TEM, SAED analysis and photoluminescence, to prepare naphthalocyanin dye doped silver nanocolloid and to carry out luminescence studies. This is the preparation procedure of the sample. We weighed out 20 mg of silver nitrate and added it to 150 ml of deionized water and mixed well. 10 g of chopped leaves are boiled and filtered out. 1 ml, 3 ml and 5 ml of the extract are added to 30 ml each of silver nitrate solution which is prepared earlier. After keeping for 3 days, we can observe that the change in the color of the samples occurs from yellow to orange red, which indicates the formation of silver nanoparticles in the solution. Each of these samples are equally divided to separate bottles and to one set of these samples, gamma irradiation is carried out. This picture shows the samples before and after irradiation. The figure itself shows a color change of gamma irradiated samples to pale color which suggests the elimination of agglomerated nanoparticles. This is later confirmed by TEM and SAED analysis. This is the TEM and SAED result of samples without gamma irradiation. This shows silver nanoparticles with average particle size of 43.89 nanometer. The particles are agglomerated with anisotropic nature. The individual particles have hexagonal and spherical-like structures. After gamma irradiation, the size of the sample got exactly reduced to half of its initial value, that is to 21.33 nanometer. The agglomeration of the particles got eliminated and the particle is found to have spherical morphology and are FCC crystalline in nature. In the optical absorption studies of the samples by using a double beam UV visible spectrophotometer JASCO V550, it is found that in the normal samples, the maximum absorbance occurs at 444 nanometer and this is for maximum concentration of leaf extract. As the concentration of extract increases, the broadness of the peak decreases. From the results of the gamma irradiated samples, it is found that the intensity of absorption of the samples are less than that of the normal samples. This is due to the reduction in particle size to nanoregime. As the gray dosage increases, the percentage of absorbance found to decrease. Later, the band gap of the silver nanoparticles are evaluated with the help of Tok plot and is found to be comparable with that of the actual theoretical values. This shows the verification of Lamberts Law. From the normal sample, it is found that as the concentration of extract increases, the intensity of absorbance increases linearly. Intensity versus dose rate graph of gamma irradiated samples shows the maximum absorbance decreases linearly with the dose rate. The silver dye composite is prepared by the method given here. The photoluminescence studies gives an emission at 486.5 nanometer which is in the blue region. This result can be used in photoluminescent material fabrication. These are the results of this work. Silver nanoparticles are biosynthesized and are characterized by different characterization techniques. It is found that by gamma irradiation, the agglomerated nanoclusters got eliminated and the size of the nanoparticles are reduced to half of its initial size. The band gap energy of the silver nanoparticles are also comparable with that of the standard values. From the photoluminescence studies, the naphthalocyanin dye doped silver nanocolloids shows emission in the blue region, which makes them applicable in the fabrication of blue LED. Feel free to discuss the work with me. Thank you.